Hello guys, welcome to this video. In this video we will be continuing all our previous explorations about all the functions and developments that we did, and in this video we shall also find out more about the properties and all the different discoveries that we can make about this exact function and the distributions that we are studying. And meanwhile there would be a lot of solved problems as well, so just head forward to the video. We can start over from there. So as we have talked about, in this section we are going to introduce some new concepts, and this integral that we will be talking about is basically 0 to pi cos square x dx. Now this is a trigonometric integral, and it's not an indefinite one, it's a definite one. But we have also learned in theory that to evaluate definite integrals we might also want to need to evaluate the indefinite first if it's available, and simply putting the limits we can find out the rest of the value, right? Now what is the basic fundamental idea behind introducing this antiderivative here? You see, cos square x is basically whenever you have a power or a perfect power of a sin x or a cos x, they can be evaluated in terms of linear sine and cos x functions. So recall the identity. 2 cos square x equals to 1 plus cos 2x, right? So we can use this identity because therefore cos square x is equals to 1 plus cos 2x by 2. I'll also be doing a trigonometric course very soon where you will know how to do this trigonometric functions and all. So for now, once we complete this integral, there will be some supplementary videos added at the end of the video, because what we have done is we have put every video in one video together. So the necessary things that are required for doing this integral are also put at the end. So that is how we ensure that we do have a better platform, because you do not really need to switch videos every time to understand something you do not about this problem we are discussing. Let's say we are discussing this problem and do not understand, or you had forgot some parts of how to do the integration, so the necessary videos will also be added in part to them. Anyways, so 0 to pi 1 plus cos 2x by 2 dx will be integration of half dx from 0 to pi, and we will also have 0 to pi cos 2x by 2 dx. Now half dx will basically be pi by 2, and for this part we will have 1 by 4 sine of 4x from 0 to pi, and as we know, integral multiples of pi for sine x will always give you a 0, so this will give me pi by 2 as my final answer, and we shall proceed from here on as well, because let me just write down the answer. It's 0 to pi cos square x dx equals to pi by 2. So we shall proceed from here on. You will see a few supplementary videos which I suggest you also learn, because well, if you have seen it earlier you can skip that part, but if you haven't seen that video before, you can just go on and learn that stuff as well, because everything here is educational and it will be directly related to our probability course and our integration course as well. So here we have our 4 examples which we are going to solve. So the examples are a bit actually in increasing order of difficulty, except the last one. So as you can see, the first one is simply a polynomial with a negative power, in fact, but it's still a polynomial. The second one is sine of log of root x, and whenever I say log in terms of calculus, until I mention specifically, it would always mean a log with a base of e, because it basically is the natural logarithm. And if I were to say some other ways, let's say the log base 10, then I would actually mention it, or I would just write it like that. Okay, right. So let's do the problems one by one and see if we can recall how we were able to solve these problems in the last video. So solution number 1. Now given f of x is equals to 3x square plus 5x to the power minus 3, right? Now we want to have the derivative of this thing. Now if we remember correctly, whenever we have sum of two functions or two or more functions and we were required to find the derivative, we use the actual formula that derivative of sum of two or more functions is equal to sum of the derivatives of the function. So what we do is we individually differentiate each of the terms, like 3x square here and 5x to the power minus 3 here, and we can just write the answer as follows, right? So what is the derivative? Well, for polynomials of the form x to the power n, we remember the answer is n into x to the power n minus 1, right? So this would give us 3 is a constant which shall remain as it is, and for x square we should have 2 into x to the power 2 minus 1. Similarly for the other one we should have 5 as it is, and then we should have minus 3 x to the power minus 3 minus 1, right? According to the rule, and I'll just write the rule here. ddx of x to the power n is just n into x to the power n minus 1. We are following this rule, right? So this would give you 6x minus 15 by x to the power 4. This is our required answer for number 1, right? Okay, so this was a bit easy. Let's go for number 2. Given f of x is sine of log of root x, right? Okay, now firstly we would like to explore some properties of log. So firstly, since log of x to the power a is just equals to a log x, okay, so it is true for all real a. In fact, so since it is true for all real a and a not equals to 0 would be the only factor, because the otherwise then only the value of the log becomes 0, and we do not really need this. But in that case what we can write is f of x equals to sine of half log x, right? This is because root x is simply x to the power half, so sine of log of root x would be sine of half log x. Now remembering the chain rule, we understand that this is a composition of two functions, right? If we were to write the composition as follows, we can do it like this. Let f1x equals to sine of x, and let f2x equals to half log x, right? Then we can write f of x equals to f1 f2 x. So f1 of f2x, which basically means this is just f1 of f2x. And the chain rules said us that when we differentiate a function of this composite kind, what we get is f dashed x should be equals to f1 prime, and the argument should be f2 of x multiplied by f2 prime of x. Okay, so how do we do that? So we need to find the derivative of f1 and f2 first, which are basically the standard derivatives. Since f1 of x's derivative is just cos of x, and f2 of x derivative is just half, will remain as it is because it's a constant, and log of x evaluates to 1 by x. Therefore f dash x should be f1 prime of f2x into f2 prime x, right? This would give me cosine of 1 by it's actually f2x, so not this. So cosine of half log x by 2x. This would be your answer for the derivative. And just using chain rule, as I've told you, by using the method of layers to find out what function comes first, and we go all the way up to the function x. We can also see using that first here sine comes. So if we first write cosine of x, where x is this thing, then we go inside sine, we have half log x, so we differentiate half log x to find it is 1 by 2x, and we just multiply it by 1 by 2x. So in both ways it can be done, and it's not really very intuitive, but obviously it's a good practice for the problems that we have done before, and a typical problem for chain rule. Next one, e to the power 5x log of sine of e to the power x. So this is our given problem, and if we wanted, we can actually use the chain rule again, and we would have to, but we would try it in a more fashionable way like this one, so it is easier to understand and not just some random answer. Because when we use the chain rule for real, we use the theory of composite functions, we actually get a good idea of what's going on and a better method to solve every problem, right? So first of all, this is a product of two functions, right? So let u of x equals to e to the power 5x and v of x equals to log of sine of e to the power x, okay? And by using the derivative of product of two functions, we get, since f of x is just equals to u of x into v of x, what we get is f dashed x is equals to u prime x into v of x plus u of x into v prime of x, right? So this is the formula, and since u of x equals to e to the power 5x, this one is an easy one to derivative, because you just find out the derivative of e to the power x first, which is e to the power x itself. So this thing will repeat itself multiplied by 5 because of the 5x, okay? So this is just 5 e to the power 5x. Now for vx, things are a bit different. So also vx equals to log of sine of e to the power x. So it's a triple layered function, right? So let us do that in a more systematic manner of how I'll show you how to do it in a more systematic manner using the chain rule only, and not using the fact that we first do it log and then we do a sine and then we do a exponential, okay? So let v1 of x equals to log of x, v2 of x equals to sine of x, and v3 of x equals to e to the power x. Then v of x is simply v1, v2, v3 of x, right? It's a triple composition. Now how do we do something like that? So to do something like that, what we do is we consider g of x equals to v2 and v3 of x, which simply is sine of e to the power x. Okay, then v of x would just be equal to v1 composition of gx, right? By chain rule, v prime of x would just be equal to v1 prime of gx into g prime x, right? Now what is v1 prime x? We know, since v1 of x is log x, then we know that v1 prime of x is just equals to 1 by x. Therefore v prime of x would just be equal to 1 by gx into g prime x, or in other words g prime x by gx. Okay, now to find gx, since g of x is equals to v2 composition v3 of x, or in other words v2 of v3x, then again by using the chain rule, we have g prime of x equals to v2 prime of v3x multiplied by v3 prime of x, right? So this v2 prime of v3x into v3 prime x, and we can see that v2x was sine x and v3x was e to the power x. So their derivatives in fact are v2 prime x would give you cosine of x or cos x, and v3 prime x would be e to the power x itself. Then since v2 prime x is cos x, this becomes cosine of v3x, and v3 prime x is just e to the power x, so it's e to the power x. So this becomes e to the power x cosine of e to the power x, right, which is g prime of x. Then the actual answer would become, therefore v prime x would just be e to the power x cos of e to the power x divided by sine of e to the power x, which would just mean e to the power x cot of e to the power x. This is v prime x, and we go back to the top and we see that u prime x was 5 e to the power 5x. Therefore, since we consider g of x equals to v2 and v3 of x, which simply is sine of e to the power x. Okay, then v of x would just be equal to v1 composition of gx, right? By chain rule, v prime of x would just be equal to v1 prime of gx into g prime x, right? Now what is v1 prime x? We know, since v1 of x is log x, then we know that v1 prime of x is just equals to 1 by x. Therefore v prime of x would just be equal to 1 by gx into g prime x, or in other words g prime x by gx. Okay, now to find gx, since g of x is equals to v2 composition v3 of x, or in other words v2 of v3x, then again by using the chain rule, again by using chain rule, we have g prime of x equals to v2 prime of v3x multiplied by v3 prime of x, right? So this v2 prime of v3x into v3 prime x, and we can see that v2x was sine x and v3x was e to the power x. So their derivatives in fact are v2 prime x would give you cosine of x or cos x, and v3 prime x would be e to the power x itself. Then since v2 prime x is cos x, this becomes cosine of v3x, and v3 prime x is just e to the power x, so it's e to the power x. So this becomes e to the power x cosine of e to the power x, right, which is g prime of x. Then the actual answer would become, therefore v prime x would just be e to the power x cos of e to the power x divided by sine of e to the power x, which would just mean e to the power x cot of e to the power x. This is v prime x, and we go back to the top and we see that u prime x was 5 e to the power 5x. Therefore, since f dash x is just equal to u prime x into v of x plus u of x into v prime x, we can see it is equal to 5 e to the power 5x into e to the power x cot of e to the power x plus e to the power 5x. Actually this one would be only vx, so not this part. So it should be 5 e to the power 5x, and vx is just sine of e to the power x plus e to the power 5x into e to the power x into cot of e to the power x, right? And what we can do is as follows: we can take e to the power 5x common. What we get is 5 sine e to the power x plus e to the power cot of e to the power x, which is the answer for our derivative. So as you can see, this question was on the harder side of the derivatives, so we needed to have some composition to do that. Then again we can do number 4, but first 1 and 2 were a bit easier, but then 3 was a bit tougher because of the composition and the number of functions involved. So that's how we use chain rule to advantage. We try to break it one by one, and we try to find the exact answers by following the rules of chain rule, right? So it's not really that much of a hard task, but then again it's not an easy task either. So you need to understand the concepts very well. The fundamentals should be grounded to you. Okay, number 4. So number 4 was root x sine of root x. F of x equals to root x into sine of root x. So firstly, as we can see, it is a product of two functions, namely, so let me write down the names for this functions. Ux equals to root x and v of x equals to sine of root x, right? So what we can do is we can firstly write that then f of x equals to u of x into v of x, right? Then by the product rule, f dashed x would be equal to u prime x vx plus ux v prime x. Now u prime x is an easier one because it's just x to the power half. Now u prime x is just like ddx of x to the power half, which basically is half into x to the power half minus 1, or this just becomes 1 by 2 root x, right? But for vx, since it's a composition of two functions, what we define is as follows. We define v1 of x equals to sin x, v2 of x equals to root over of x, right? Then we have v of x equals to v1 composition v2 x. Well, obviously v2 is equals to u, but we can just have a different name because it's in a different function, so it wouldn't matter that much. Now, using the chain rule, we have v prime of x equals to v1 prime of v2x into v2 prime of x, right? And we know v1 prime of x is cos x, so it's basically cosine of v2x into 1 by 2 root x, which just gives me cosine of root x by 2 root x. And when we put that back, what we do get is as follows. So putting everything together, our actual answer to f prime x would be, so u prime x was 1 by 2 root x and v of x was, I think, sine of root x, plus u of x was just root x and v prime x is cos of root x by 2 root x. This gives us sine of root x by 2 root x plus cos of root x by 2. So we can just simplify it and do the LCM to write this as 1 by 2 root x into sine of root x plus root x cos of root x, which is the answer to this problem. So as you can see, this problem was also a little bit on the difficult side, but then again, all of these problems are a bit on the difficult side. We will try to do a few more problems in the next lecture on derivatives. Only after then we can move on to integration and its basics, because the chain rule and all of this must be very clearly understood before we can move to anything else. And there are a lot of things in derivatives that we will not be doing, like mean value theorem, which should be saved for the derivative section, and we will be covering all of this back when we will be covering calculus alone and not probability. But for now, doing a few problems on chain rule and how to understand this is enough, I think. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also, you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.